welcome back to Chemistry Made Easy with Bright Edo. In today's video lesson, I'll be teaching on how to write the equilibrium constant expression for reactions. I'll be giving us different examples in order to understand this concept better. So let's quickly move over to the first example, which is example 1. First, let's say nitrogen gas, nitrogen gas reacts with hydrogen. Nitrogen gas reacts with hydrogen gas, so we get a product which is ammonia, NH3. Now we need to balance the reaction, and ammonia is in the gaseous state. So we need to balance the reaction. So here basically should be 2 moles, and here should be 3 moles, and here should be 1 moles. Now basically, to write the equilibrium constant expression for this reaction, that is the mass action expression, is simply done by a formula which is K equals the product over the reactants. The product over the reactant. So ammonia here, NH3 is the product over the reactant. Now, gases and aqueous species appear when writing the equilibrium constant expression for reaction. It should be noted that gases and aqueous solutions appear when writing the equilibrium constant expression for reactions, whereby liquids and solids do not appear. Whereby liquids and solids do not appear when writing the equilibrium constant expression for reactions, but gases and aqueous solution appeared. Now, what will be the answer to this question? So first, this is the product. So the equilibrium constant expression, which is K, will now be equal to NH3 in a bracket over nitrogen gas times hydrogen gas. Now, the next step to be taken is to take the coefficients of the reacting species to be the power. So for ammonia, the coefficient is 2. So 2 here is going to be the power. Whereby for hydrogen, the coefficient is 3. So 3 becomes the power. So for nitrogen, the coefficient basically will be 1. So 1 becomes power. But sometimes you just leave it like that. It stays the same. So it stays the same thing. So basically, this is the equilibrium constant expression for the formation of ammonia. It must be noted that gases and aqueous solution appear when writing the equilibrium constant expression for reactions. Now let's take another example. Let's say this one now is between hydrogen gas reacting with bromine gas to get HBr gaseous state, and basically to balance this reaction, it becomes 2 moles of HBr. So let's write the equilibrium constant expression for this reaction. So K becomes products over reactant. These are the product, whereby these are the reactants. So basically it becomes HBr in the gaseous state. Recall, for gases appear when writing the Kc expression or the equilibrium constant expression for reactions over the reactants, which are H2 hydrogen gas plus bromine gas. Now it becomes the coefficient of HBr should be raised at the power. So basically it becomes 2. Okay, so in writing equilibrium constant expression, the reaction first must be balanced. Now let's take another example, example 3. So this reaction will be for the decomposition, thermal decomposition of calcium carbonate. Okay, so when this occurs, we get CaO, which is quicklime or calcium oxide, plus carbon dioxide, which is in gaseous state. So this is solid, whereby this is solid. So what will be the equilibrium constant expression for this reaction? So K, that the equilibrium constant expression for this reaction becomes product over reactant. Now, you can see here that it is between solid, solid, and gas. Recall I said liquids and solid do not appear when writing the equilibrium constant expression for reaction. So basically, we only take the gaseous species, which is CO2. And it should be noted that they are taken as one. So let's say if we want to divide with CO2, just say it's taken as one. So when you put one here, it's still same as writing only CO2. So basically, for the equilibrium constant expression, solids and liquids do not appear when writing the equilibrium constant expression. So let's quickly move over to the last example. Now, in this context, let's say HF, which is in the aqueous form, reacts with hydroxide ion, aqueous form. So what's going to be our product? We'll get chloride ion plus H2O, which is water, liquid. So what will be the equilibrium constant expression for this reaction? Basically, K becomes product over reactant. These are the product, whereby these are the reactant. So liquids do not appear when writing the case equilibrium constant expression for reaction. So basically it becomes fluoride ion over the reactant, which is HF, OH minus. So basically these are the answers to the question. So you can see how to write the equilibrium constant expression for reactions. Take note, liquids and solids do not appear when writing the equilibrium constant expression. Now, to be specific, sometimes you see the word Kc and Kp. For Kc, it is written whereby the equilibrium constant is written in terms of concentration, like aqueous solution, while for Kp, it talks about pressure, partial pressure for gases. So to be specific for this, since that they are all aqueous solutions, it becomes Kc. But for others which are gases, you just say Kp. Okay, so basically this is how to write the equilibrium constant expression for reactions. Do well to hit the subscribe button and also share this video with your friends. Thanks for watching.